Our project is called HYGIEIA. We named it after the Greek goddess for water. It's a collaboration between three entities, between SOGECLAIR, HYGIEIA and TORRECID. The main objective of the project is to produce a water container for grey waters in the cabin area of an aircraft and to give it an internal coating which is antimicrobial so that there isn't any accumulation of biofilm. The idea is in this case that the water be stored and used for flushing the toilet. The problem is if there's an accumulation of biofilm within the container, this water which will be sent to the toilets under pressure may cause the mechanisms which are hydraulic to be blocked, in which case the system will not function properly. So it's essential and important element in the functioning of this new recycling water system. However, there are other considerations which are important. The principal one is weight saving, of which this process of saving grey waters may reduce the actual weight of water used in a single flight by as much as 30%. So for this project, it was decided to use high technology thermoplastics, which are typical of aircraft, for the application because of the strength, because of the resistance to both high temperatures and low temperatures. And in the case of the project, we decided that we were going to injection molding being the most common form of manufacturing, which is expensive to develop initially, but once it has been properly developed, can be manufactured in series relatively cheap. And this is very important as well.
Our approach in the project was to develop antimicrobial coatings and deposit them on the inner surface of the container. Coatings are a useful tool to give new functionalities to a component without affecting much to its weight. Biofilm growth occurs on the inner surface of the water container. Consequently, the antimicrobial activity of the material is only required close to this surface. The use of coatings reduces drastically the number of active particles or materials needed to obtain the antimicrobial efficacy, and therefore keep the eventual costs and technical complexity under reasonable limits. Finally, it's important to note that the use of coatings such as paints or PVD will make it possible to apply the solution developed within the HYGIEIA project to other components of the grey water reuse system, and even other applications in which biofilm formation is not desired. Regarding the testing procedure, a three-stage validation plan was established, in which three types of samples were tested: flat samples, curved samples, and the final container.
And for us, the most difficult part is for the container itself with the internal antimicrobial lining to survive a series of shock and vibration tests. These take place in an industrial vibration and shock table, which applies most of the conditions which can happen during the lifetime of an aircraft in their most severe condition. We're very happy with the outcome of the project because from the point of view of biofilm, it's almost 100% effective. And from the point of view of the tests for shock and vibration, as far as we know at the moment, because we're just getting to the very end of the tests, it works perfectly and doesn't break.